Today we're going to learn about writing variable expressions for a geometric sequence. Now this will be an explicit equation or explicit expression, which means it gives us any term we want. This will be new for many of you. So the first thing we're going to do is we're going to make sure we remember that n represents a term number. Right? So if we want the term 1, we'd replace wherever n is in our expression with 1. If we want term 7, we'd replace wherever the n is with 7. Now, the way we write these expressions is a geometric expression is, a geometric sequence is multiplying from one term to the next. So let's do a very, very simple one. So let's do something like 1, 3, 9, 27, 81, 243. So hopefully you can all easily see that what we're doing is we're multiplying by 3. Now, the way I try to remember that a geometric sequence or how to write it is I'm multiplying by 3 repetitively over and over and over and over again. I'm multiplying by 3 here, I multiply by 3 again, I multiply by 3 again, I multiply by 3 again, I multiply by 3 again. So if you're multiplying by 3 a bunch of times, the easiest way to represent that is with an exponent. So what we do is we take 3, which is what we're multiplying by, and we raise that to the exponent of n, and we put a -1 after it. And there's a reason we put a -1 after the end. Because if you recall, anything raised to the 0 exponent is what? 1, right? So if we want to get the first term to be a 1, what we need to make sure is that we technically don't multiply by 3 at all. So what we're going to do is we're actually going to put a number in front of this 3 to the n-1, which is our first term. I'm going to put a 1 times, or maybe I'll put a dot, times 3 to the n-1. Now think about this again. Hopefully this will make sense now that if I plug a 1 here to find my first term, what's 1 minus 1? I'm really putting an exponent of 0 on the 3, which means I multiply by 0 threes, or 1, and 1 times 1 is 1. If I plug a 2 here to get the second term, and now let's remember this is the first, second, third, fourth, and so forth. If I plug a 2 here, what's 2 minus 1? 2 minus 1 is 1, which means I'm going to multiply by 1 3. And I only want to multiply by 1 3 to get to that second term. So if I multiply 1 by 3 one time, I get to the second term, which is 3. If I want the third term and I plug a 3 here, then what's 3 minus 1? In a sense, it's saying 3 minus 1 means I'm going to raise 3 to the squared, 3 squared, and I'm going to multiply that by that leading coefficient of 1. That means I'm multiplying by how many 3's? 2. And how many 3's do I need to multiply by to go from the first term to the third term? 2 3's, which gives me 9. So this n-1 basically says that when we're multiplying by 3's, we're going to multiply by a certain amount to get to the nth term. Like if we wanted to get to the fourth term, we really only need to multiply by 3 times. If I want to get to the fifth term, or sixth term, I guess that is, the sixth term, I'm going to multiply by 3 5 times, or 1 less. Let's do another example. This one might have been with the leading coefficient of 1, or this leading 1. Sometimes that might have been a little bit difficult or a little bit confusing. Let's do another one. Let's do something that actually maybe even goes down. So in other words, let's do something like 64, 32, 16, 8, 4, and so forth. Well, again, you need to first figure out what you're multiplying by. And if it's hard for you to figure out what you're multiplying by, just remember to take a term. And normally if they give you the second and first term, you'll take the second term, which is 32. You'll divide it by the first term, which is 64. So you take the second, divide by the first, and that will give you what you're multiplying by, which is 1/2. Again, you would say, yeah, we're dividing by 2. But in geometric sequences, we always want to consider it or think of it as multiplication. So I'm multiplying by 1/2. So what I'm going to do is I'm going to put 1/2 in parentheses, and I'm going to raise that to the n minus 1. And the reason I want to do n minus 1 is so I can use this first term as a starting point, 64. Because again, if I plug a 1 here now, what is 1 minus 1? 0. And what's 1/2 to the 0 power? Just 1. So I'm not changing 64. It's 64 times 1, which is 64. But if I plug a 2 here for the second term, because remember, n means the second term. If I plug a 2 here, 2 minus 1 means I have 1/2 one time that I'm going to multiply by 64. And what's half of 64? 32. If I want the third term, I plug a 3 here, and then I get 3 minus 1 is 2. So I have 1/2 raised to the 2, or 1/2 twice. So 1/2 times 1/2 is 1/4. And 1/4 times 64 is 16. Or again, maybe I should be even writing this out so you can see it. If I take 1/2 and I plug in a 3 for my third term, that equals 64 times 1/2 squared, which means that's 64 times 1/2 times 1/2. And again, if I times by 1/2 twice, I get to 16. So this is the way that they'll have you write your explicit equations or expressions. Again, we could put an AN equals in front of it to make it a full-fledged equation, but I think a lot of times they'll just ask for it in Excel anyway to be just an expression without the AN equaling. If you have any questions, please bring them to class and I will answer them then.